Hi, here we go again. So today I would like to introduce about the Lab 03, which is about the exploring spatial data and tells interacting with maps as well as the tables, charts, graphs, and multimedia that are associated with them. It is built on data-driven workflows that generate intelligent data visualizations that smart maps are built on. It's fascinating because it allows users to interact with the data while still remaining within the context of the map symbolism. Many interesting tutorials can be found on the site, one of which is use DEM for terrain mapping, which demonstrates how to extract terrain in 3D. So the content for this Lab 03 is comprised of a number of selected chapters, the most notable of which are chapters 9, 13, 14, and 17. According to the training provided, it can be seen that a great deal of emphasis is being placed on digitalizing the Earth. So for the next is I would like to show about the tutorial. In this video tutorial, I demonstrate how to complete task 1 of chapter 17. Calculate the least cumulative cost distance. So here, I would like to begin. The first one is that we have to connect to the Chapter 70 database in our catalog, launch ArcMap, rename the data frame tax1, and add source grid, cost grid, and path grid to tax1. Ignore the warning message about the spatial reference. Okay, next is the second steps. Clear R2 box. Window to open R2 box. Set the current workspace as the Chapter 17 database. Double-click the cost distance tool in the spatial analysis tool or distance toolset. In the next dialog, select source grid for the input raster. Select cost grid for the input cost raster. Save the output distance raster as cost distance and save the output backlink raster as cost directions. Click OK to run the command. And lastly, cost distance show the least accommodative cost distance from each cell to a source cell. You can use the identify tool to click a cell and find its accumulative cost. So the conclusion is in accordance with specific data recorded in accordance with the regulations, it is possible to modify and design the handling of digital spatial data. And once data is recorded as a reflection of certain attributes, it is easier to understand the data.